So by combining elements, we have found one method of shortening the work of circuit analysis. Another useful shortcut is the application of the ideas of voltage and current divisions. So voltage division is used to express the voltage across one of several series resistors in terms of the voltage across the combination. Meaning, the voltage across here is divided between the resistors that are connected in series. Now for this case, we have V is equivalent to V1 plus V2. We have V equivalent to V1 plus V2, where V1 and V2 can be expressed in terms of the current I. So V1 is equivalent to I times R1 plus I times R2. So solving for I, we have I is just equivalent to V over R1 plus R2. So looking at the individual voltages, so V1 in terms of I is just I times R1. So we use this equation and substitute this I here. So we have I is equivalent to V over R1 plus R2 times R1. Or if we rearrange this equation, so V1 equivalent to R1 over R1 plus R2 times the voltage. So this is what is meant by expressing the voltage across one of several series resistors in terms of the voltage across the combination. So V1 here is the voltage across one resistor, and this V here is the voltage across the series combination of resistors. So for V2, have V2 is just I. Let's circle this. So V2 is just I times R2. So using same method, R1 plus R2 times R2. We have V2 is equivalent to R2 over R1 plus R2 times V. So for the general equation for a voltage divider, so we have K equivalent to RK over R1 plus R2 plus Rn times V. So this is the general equation. For current divider circuits, this is the dual of voltage division. It is used to express the current in one of several parallel resistors in terms of the total current. We have total current here. So meaning the total current here is divided between the number of resistors in parallel. So for current divider circuits, we apply KCL to the top node. We have I equivalent to I1 plus I2. Let's express the currents I1 and I2 in terms of the voltage V. So since they are connected in parallel, R1 and R2 have the same voltages. We have V over R1 plus V over R2. So solving for V, we have V equivalent to I times 1 over R1 plus 1 over 2. Or we can rewrite this equation as I times R1 R2 over R1 plus R2. Let's take a look at I1. So I1 is just V over R1. So let's use this equation to substitute V. We have I times R1 times R2 over R1 plus R2 times R1. So R1 cancels out. We are left with R2 over R1 plus R2 times I. So we can see the current I1 is expressed in terms of the total current I. Now for I2, we have I2 is equivalent to V over R2. We have I times R1 times R2 over R1 plus R2 times R2. R2 cancels out. We are left with this R1 over R1 plus R2 times I. Now for the general equation for current division, we have IK equivalent to 1 over RK over 1 over R1 plus 1 over R2 plus not plus dot 1 over Rn times I.